All right, so the first question in that 8-2 warm-up was determine whether or not the sequence is arithmetic. If it is, find the common difference. This one, oh, most of you got right. I think all of you, actually. The common difference, it was decreasing by 2. So, yes, it's arithmetic, and the decrease, or the D, which is the common difference, is -2. Everybody's done that one. Yeah. Second question said write the first 5 terms of the arithmetic sequence. So if A sub 1 is 8, that's your initial one, and you're increasing by 3 every time you're going from 8 to 11 to 14 to 12 to 17, sorry, to 20. Just pay attention whether it says first 5 terms or first 4 terms. You want to make sure you give that exact amount. Again, everybody got that one. The third one said use the information for number 2 to complete the following. Find the formula for A sub n of the arithmetic sequence, and then find the sum of the first 25 terms of the sequence. So the first thing you had to find was the formula for A sub n. And that equation is here. So yesterday we talked about 2 new equations. How to find A sub n, or the formula for A sub n if it's arithmetic, and also the sum, which this uses both. So the A sub n is A sub 1, or the initial A, plus D times n minus 1. If the first A was 8, the D was 3, and you simplified it. This is your equation for A sub n, 5 plus 3n, or 3 plus 5n, same thing. I mean 3n plus 5, same thing. I got it. And then you had to, for the second part, figure out the sum. So the sum of an arithmetic sequence is n over 2 times the first term plus the last term. So the first term we knew was 8. This time they're telling you 25 terms, which means you had to figure out what A sub 25 is. So if you use this formula and you plug 25 in, you should have gotten that A sub 25 is 80. And then all you got to do is take it and plug it in to this equation, which is here. So 25 over 2 times 8 plus 80 is 12.5 times 88, which is 1,100. So first you had to get the equation, then you had to get the last term, and then you had to plug it into the sum. Questions on that one? The fourth one said find the sum of the first 50 positive multiples of 5. So the n is 50. There's 50 multiples, right? So I know the n. The first multiple of 5 is 5. The 50th multiple of 5, so Karina, this is yours, right? How did you figure out the 50th multiple of 5?
I did 50 times 5.
Good. So you can either, like if you're unsure, if it's a multiple, it's going to be that times the number. But if you're unsure and you wanted to actually find an A sub n, you could have. Like I could have done A sub n equals the first one, which is 5, plus the change. So the difference from this multiple of 5 to the next multiple of 5 is 5. N minus 1, I would have gotten 5 plus 5n minus 5. These cancel. And I get 5n. So if you're unsure of how to find it, which you could just multiply the number of multiples times the actual multiple. But if you're unsure, you could always do that. And then the 50th term would have been 5 times 50, which is 255. Or sorry, 250, which is here. And then it's n over 2, which ends up being 25 times 5 plus 250, which is 255. And that gives you 6,375. Questions on that one? So it's another great SAT question, right? They would love for you to sit there and go 5 plus 10 plus 15 plus 20 plus 25 plus 30, because you can do it. It just wastes your time. And the last one said find the partial sum. So it's the same formula that we used, n over 2 times first plus last. The n we said would be the number on the top as long as the number on the bottom is 1. So from 1 to 10, think about counting your fingers. There are 10 of them. But if I say throw 0 in there now, that is 1 more than that, which means my n is 11, which is here, divided by 2. The first term comes from the initial one from this set, which means if I plug 0 in, that's the first one. And I'd get -3, which is here. And then the last one still stops at 10. That's still my upper bound. So I plug 10 in. 20 minus 3 is 17. That's here. So then I'd get 5.5 times 14, which is 77. I would say this is the one you guys miss the most, so be careful on it. So if this notation is what confuses you, last hour I said it this way, so if this confuses you, ignore me, but if it makes sense, then do it. It's the number at the top minus the number at the bottom plus 1. All the time, no matter what the term is on the bottom. It's the top number minus the bottom plus 1. So if at the top it's 10 and the bottom it's 1, it'd be 10 minus 1, which is 9, plus 1, which is 10. If it's 10 at the top and 2 on the bottom, it's 10 minus 2, which is 8, plus 1, which is 9. It's not so bad when the top number is 10. It gets a lot harder when the top number is 256 and you're trying to count from 2 to 256. So as long as you understand that it's relative to the bottom being 1, you should be okay. Questions on any of the warm-up? That's 50% of your quiz. That's tomorrow. Okay. Tomorrow's quiz is going to cover 8.1 to 8.2. Okay, 8.1 was all your general sequence questions. So you're doing something like 1 and 2 where it says find the first blank number of terms in the sequence. Again, make sure you read directions. It might say 4, it might say 5. And assume that n begins with 1 so that you know you're starting at 1 and you're plugging those in. 3 and 4 were where you were finding a specific term like a sub 5 or a sub 11. You're just plugging those numbers in. Again, just be careful, don't make silly mistakes on that stuff. 5 and 6 should say find, not select. Find the first 4 terms of the sequence defined recursively. So remember, recursively just means you need the first one to get to the next one. And biggest mistake on the recursively is not including the first one. So it will give you a sub 1. Make sure you include a sub 1 in your answer. So for those, because it's 4 terms, you're really only finding the next 3. If it said 5 terms, you'd be finding the next 4. Are we good on those? Those are easy, right? Yes? Overall, good? Feel good about it? Feel confident? Yeah, okay. So the sum is what's on the bottom. The notation, I was like in a fight with Microsoft Word. It would not put them at the bottom. So this is obviously supposed to go at the bottom and 15 is supposed to go at the top. So if that throws you off, it should be a 15 and then the bottom is j. This time the variable can change. J equals 1. So I want to be really clear that we just learned a formula for sum in 8.2, right? But what kind of series does that work on? Only arithmetic. So this one is actually arithmetic. You could do it both ways, okay? Right? If I were to solve that, you would be increasing by the same amount every time. You'd be decreasing by 2 every time. So this is arithmetic. If it's not arithmetic, so I think this one has a power in it. Yeah, if it's raised to a power, it is not arithmetic. You cannot do it with the sum formula. You have to plug in 2, then plug in 3, then plug in 4, and then add the numbers together. So our formula, our n over 2 times first plus last, only works for arithmetic. Just like our a sub n formula is only for arithmetic sequences. So both of the formulas that we learned yesterday only apply to arithmetic sequences. Be careful, don't apply them to your initial sequences. And we're going to learn more for geometric. So you want to make sure you get to know these really well, that these are just arithmetic. So for 7 and 8, you're starting at the bottom and you're working way up to the top. So for 7, you can either plug in 1, then 2, then 3, then 4, then 5, then 6, then 7, then 8, then 9, then 10, all the way up to 15. Or because it's arithmetic, you can actually use the formula. For number 8, you have to plug in 2, then 3, then 4, and add them together at the end. You can't use the formula.
How did you know it was arithmetic?
So if you just like look at that number and I solve for j, technically that would be j, like if I divided by 2, I would get j minus 2. That means I'm taking j and constantly subtracting 2 from it. But if you don't catch it and you go to plug in the first couple, you should see the pattern. You should see it increase by the same amount or decrease by the same amount. Anything raised to a power, you're going to rule out immediately. It's not going to be arithmetic. And multiplication by itself may not be arithmetic, but it depends on the scenario. All right, then we get to identifying if it's arithmetic. So 9 and 10 is just yes or no, and what's the common difference. 11 is writing the first 5 terms, then figuring out if it's arithmetic, finding the common difference. 12 is your formula, so that's the one we just went over. This would be a sub n equals a sub 1 plus d times n minus 1. 13 and 14, you can simply add or subtract d on until you get to all 5 terms. 15 and 16 is now using this sum formula, so this is your n over 2 times first plus last. It says use the finite arithmetic sum formula to find the sum. I know you can add 3 plus 5, well, hope. You can add 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17 plus 19 plus 21. It's not the goal. If you want to do that to check your answer, go for it. But if you just give me that answer without me seeing the work for that formula, you will not get credit for that question. Okay? Don't make that mistake.
Are we going to have a calculator on this?
Nope. Because then it would be even easier to add 3 plus 5 plus 7, right? Yeah. Some calculators have summation notation and some don't. It's just not fair. We're on our own. We're bringing it to your calculator. And then the last one is your summation notation. So this is partial sum. This is, if it says find the partial sum, this is arithmetic. The J should be at the bottom. The 48 should be at the top. So in this case, obviously, I would prefer you not plug in 1 to 48 and then add those numbers up. Use your equation. Questions for me as far as stuff being covered on your quiz. So we're actually going to come in. You'll take your quiz the first half of class, and then we're going to start 8-3 at the end. Okay. It's a quick quiz. It's only 10 questions.